Okay, so let's try to wrap up this last section, convert the following system to matrix multiplication, and solve. This is really just an augmented matrix. Well, kind of. What they really want you to do is take your coefficients and take it times x, y, z equals 10, 6, and -1. But I would probably just do this in an augmented matrix because it behavior-wise, it's kind of the same. But if we wanted to do matrix multiplication and solve, remember this is 1, 2, 3, 2, 3, 2, -1, -2, 4, times x, y, z equals 10, 6, -1. So to find what x, y, and z are, I need to find the inverse of this thing. So if we want to find the inverse of this thing, we start here. We already have a 1 on the top left, so we need to fix the rest of the columns. Row 2 minus 2 row 1s. This becomes 0. 3 minus 4 is a -1. 2 minus 6 is a -4. 0 minus 2 is a -2. Then 1 and 0. Clean up row 3 as well. Row 3 plus row 1. 1, 2, 3, 0, -1, -4. Still the same on the other side. 0. -2 plus 2 is also 0. 4 plus 3, though, is 7. 0 plus 1 is 1. 0 plus 0 is 0. So we have 1, 0, 1 down here. Finish the first column. I need a 1 in here in the middle. So I need to take row 2 times -1. 1, 2, 3, 0, 1, 4, 0, 0, 7, 1, 0, 0. It's now 2, -1, 0. I also need to clean up the top row, so row 1 minus 2 row 2s. It's now 0, 1, 0. 3 minus 2, 4, so 3 minus 8 is -5. We have 4 still. 1 minus 4 is -3. 0 minus -2 is +2. Okay, so I now clean up the first two columns. The last thing I have to do is clean up the last column. I need to take row 3 divided by 7. 1, 0, -5, 0, 1, 4, now 0, 0, 1. Okay, so the first two rows are still the same. This is now 1/7, 0, 1/7. Now I have to clean up this last column, so that would be row 2 minus 4 row 3s. To clean up the second row. So this is 0 and 1. Now 0. 2 minus 4/7 is 10/7. -1 minus 4 zeros is still -1. 0 minus 4/7 is -4/7. And lastly, I need to take row 1 plus 5 row 3. So these are the same. Okay, so -3 plus 5/7 is -16/7, so -21/7 plus 5/7. This is still 2. 0 plus 5/7 is 5/7. And so I have my inverse. So I've got A inverse is equal to -16/7, 10/7, 1/7 going down, 2, negative 1, 0, 5 sevenths, negative 4 sevenths, 1 seventh. And I have to take that times my solution matrix, 10, 6, negative 1, to get what my solutions are. Okay, so to find x, that's the first row times the first column. We've got negative 160 over 7 plus 12 minus 5 sevenths. So this is 84 over 7. So this is negative 60 plus, or negative 160 plus 84. That's negative 76 over 7 minus 5 over 7. It's like negative 81 sevenths. Y, 10 sevenths times 10 is 100 sevenths. Minus 6, negative 4 sevenths plus 4 sevenths. That's 42, so this is 58, 62 sevenths. Some odd numbers, but that's fine. 1 seventh times 10 is 10 sevenths. 0 times 6 is 0. Minus 1 seventh, that makes a total of 9 sevenths. So your solution to this would be negative 81 sevenths, 62 sevenths, 9 sevenths. A complicated solution, but again, it can be useful. And lastly, we could have word problems. We're just going to set up what the equations look like, but then you can solve from there. Normally in these word problems, when you're given the option, if it didn't tell you to use matrices, I wouldn't use them. If you use your normal ways. Colorado company makes artisanal dining room furniture. A buffet requires 15 hours for cutting, 20 hours for assembly, and 5 hours for finishing. A chair requires 5, 8, and 5. A table requires 10, 6, and 6. The cutting department has 4,900 hours of labor. Assembly 6,600 and finishing 3,900. How many pieces of each type should the company produce? So we're just going to set up the equations. So a buffet is X, table Y, or chair Y, and table is Z. So in total, for the amount of hours available, the cutting department has 4,900, so that would be 15 hours of cutting per buffet, plus 5 hours of cutting per chair, plus 10 hours of cutting for the tables is 4,900. And we repeat this process for the rest. 20 hours for assembly for the buffet, 8 hours of assembly for the chair, 6 hours of assembly for the table, and that's 6,600. And finishing is 5, 5, and 6 respectively. 5x plus 5y plus 6c equals 3,900. So these are how our equations set up. And from here you can solve by the method of your choice. I would personally just use regular systems. You can divide the first equation by 5. The second equation can be divided by 2. So those can simplify your numbers a little bit. But really it's the same type of strategies we've had for, I think 6.3 was the word problems, only they now were trying to get you to use matrices to solve them. If I put the word problems on there, I'm going to give you your choice of the method to solve them. So it's really up to you on how you want to do it. And that's all for chapter 6.